Okay, let's take a look at Chapter 5, Z-scores. And in this sequence of examples, I want to kind of reiterate what a z-score is, do a problem on how to convert from x to z and z to x, and then also look at kind of just transforming a data set from one normal distribution to another normal distribution. So I'm going to be looking at problems number 6 and number 24. Okay, so let's take a look just real quick at number 6. This one first. And so before we do that, maybe I back up and say, okay, a z-score, okay, a z-score, the definition would be is the number of standard deviations an observation is above or below the mean. Okay, so if you had a z-score of, so z of 1.2, that's telling you that whatever x value you started with, whatever observation you started with, it's 1.2 standard deviations above the mean. Okay, so if we have here our example number 6, we have a population with mean 100 and the standard deviation of 20, which, by the way, we'd have to know both of these to make it work. The computation part of z is that it's going to be the observation minus the mean divided by the standard deviation, and that'll never change. That is always how we compute the z-score, no matter what conditions, as we've seen now in later chapters. Okay, so here we go. If we have a observation of, I don't know, let's see, 108, the z-score, z would be equal to 108 minus 100 divided by the standard deviation 20. So in other words, 8 over 20, which is equal to 0.4, 0.4. Okay, if we had an observation of 88, then our z-score would be 88 minus 100 divided by 20. So in other words, negative 12 over 20, which is negative 0.6. Okay, so this is telling us that we're below, the negative sign tells you you're below the mean, right? 88 is less than 100. And the distance is 0.6 of a standard deviation. Okay, the actual distance is 12 units, but in light of the standard deviation, it's 0.6. Okay, now we could go from having a z-score to a regular score, and so just looking at the formula for z again, we had that the z-score was equal to the observation minus the mean divided by the standard deviation. Doing a bit of algebra here, we'd find that, okay, the z-score times the standard deviation is equal to the observation minus the mean. And if I add the mean to both sides, then I have that the mean plus the z-score times the standard deviation is equal to the observation. So symbolically, that tells us if z is equal to x minus mu divided by sigma, then maybe I'll say if this is true, then x is equal to the mean plus z times the standard deviation. Okay, so let's see here. If we had a z value of 1.8, still with the population parameters, mu is 100, sigma is 20, then the x value would be 100 plus 1.8 copies of the standard deviation of 20. So in other words, 100 plus 36, which is 136. Okay, so in other words, in this distribution with a mean of 100 and a standard deviation of 20, the score 136, that observation has a z-score of 1.8. In other words, it's 1.8 standard deviations greater than the mean. Okay, now let's say we had a z of negative 0.75, so we're 3/4 of a standard deviation below the mean. Well, then our x value is going to be 100 plus negative 0.75 times 20, which is 100 minus 15, or 85. Okay, so a negative z-score corresponds with a value that's less than the mean. Okay, again, we're going to pause the video and I'll let you run through some of these computations and check your work. Okay, let's take a look at number 24. In number 24, we have a normally distributed data set with a mean of 76 and a standard deviation of 12. And what we want to do is transform this into a data set with a mean of 100 and a standard deviation of 20. Okay, so in other words, we want to take, maybe I'll write it like this, we want to take a normally distributed population with these parameters and we want to turn it into still a normal distribution with new parameters. Okay, and the way we're going to do this is we're going to take our x value coming from the old distribution, we're going to first convert it into a z-score, and then we're going to convert that back into the new x value. Okay, so let's first look at an old score of, let's say, 61. Okay, so what we want to do is find its new value in the new distribution, and so the way we're going to do that, say, okay, well, let's find the z-score for 61 and under the old parameters of 76 and 12. Find the z-score and then take that z-score and change it into a new observation with the new parameters 120. And so we're going to start like this. We're going to have z is equal to 61 minus 76 over 12. So that's going to be, what's that, negative 15, I think, negative 15 over 12. So that's going to be negative 1 and then 3/12, so 0.25. Okay, and then we're going to take that z-score and say, well, then this, maybe I'll say x old, and then x new, using the same formula from before, we're going to say it's going to be the new mean 100 plus our z-score 1.25 times the new standard deviation, and we get 100, 1 1/4 of 20, that's going to be negative 25, which is equal to 100 minus that is going to be a 75. Okay, let's try one above the mean. So the old score is 85. So the z value for that is going to be 85 minus 76 over 12, which is, okay, 85 minus 76 is 9. 9 over 12, that's 3, so 0.75, 3/4. So then our new score is going to be 100 plus 0.75 times 20, so 100 plus 15, so 115. Okay, again, I'll pause the video and let you try some examples if you would like.